In this question, we have to find the value of the given expression. And the condition here allows us to neglect the squares and the higher powers of x. So let us begin term by term. So we take the first one, which is the fourth root of 1 minus 3 over 5 times of x. So fourth root of 1 minus boom here. In this particular question, we have to find the value of the given expression. And there's a condition stated here that we can neglect the square and the higher powers of x. So we begin by considering the first term in the numerator, which is the fourth root of 1 minus 3/5 of x. Now we're going to convert it into an exponent, and that would be 1. Let me write it as plus negative 3/5 of x whole raised to the power of 1/4. So this would give us 1 plus n, which is 1/4, times x, and x here is negative 3/5 of x. And we are going to neglect the other higher powers, which is the x squared and all the remaining higher powers of x. This should give us 1 minus 3 divided by 20 times x. So this is the binomial approximation for the first term in the numerator. Let's go to the second term in the numerator. So we have 1 plus 5/6 of x raised to the power of negative 6. So this would give us 1 plus negative 6 times 5/6 of x. So here you can see that the 6 and the 6 will factor out each other, and that will leave us with 1 minus 5x. Now we move on to the denominator. We consider the first term, which is the cube root of 1 plus 2x. So this could be written in the exponent form as 1 plus twice x raised to the power of 1/3. Now, like the previous two terms, here we can see that one of the term is already 1. So we do not have to worry about factoring out any term out of the expression. So we can straight away go ahead and apply the binomial approximation, and that would give us 1 plus 1/3 of twice of x. So that would be 1 plus 2/3 of x. I move on to the second term in the denominator. It's the fifth root of 1 minus x over 2. In the exponent form, we can write as 1 minus x over 2 raised to the power of 1/5. Then we apply the binomial approximation, so we have 1 plus n, which is 1/5, times x, and x here is denoted by the second term, which is negative x over 2, and we get 1 minus x over 10. Now that we have all the terms written in their approximate form, let's plug it into a given expression. So for the first term, we have 1 minus 3 over 20 times x. For the second term, we have 1 minus 5 of x divided by 1 plus 2/3 of x plus 1 minus x over 10. Now we go ahead and add the like terms. We have 2, then we're going to add 3 over 20x to 5x, and that should give 103 over 20 times x. divided by 2, then we add 2/3 of x, then we subtract 2/3 of negative x over 10 from 2/3 of x, and that should give us positive 17 over 30 times x. Now, in order to be able to apply the binomial approximation, we have to get rid of the 2 from both the numerator and denominator, meaning we have to convert it into unity. So let us factor out 2 from the numerator. So we have 1 minus 103. So we have to divide by 2. So that would be simply multiplying 2 to the denominator, which is 20. So 2 times 20 will give us 40 times x, divided by, again taking factoring out 2 from the denominator. So we have 1 plus 17 divided by 30 times 2 is 60 times x. Now we can factor out 2 from both the numerator and the denominator, and that leaves us with 1 minus 103 over 40 times x. Now what we're going to do, we're going to take the expression in the denominator up to the numerator, and that should give us 1 plus 17 over 60 raised to the power of negative 1. Now we'll apply the binomial approximation to the second expression, and that should give us 1 minus 103 over 40 times x times 1 plus negative 1, so I missed an x here, negative 1 times 17 over 60 times x. So that would be 1 minus 103 over 40 times x multiplied to 1 minus 17 over 60 times x. Now we're going to use the FOIL method, and that should give us 1 minus 17 over 60 times x minus 103 times 40 times x. Now we can reject the fourth term, which will be the multiplication of the second term in both the two expressions, because that would have an x squared term, and we can have to neglect the x squared term. So that leaves us with 1 minus 17 over 60 plus 103 over 40 times x, and the final answer would be 1 minus 343 over 120 times x. So this is the final value, so we can say the simplified value of the given expression. Let us move on to the next question. In this particular question, we have another expression and we need to simplify it, and we can neglect the square and the higher powers of x. So let us begin by approximating it term by term. So we consider the first term in the numerator, and that is the square root of 16 plus 5x. Then we can rewrite it in the exponent form, and that would give us 16 plus 5x raised to the power half. Now, in order to be able to apply the binomial approximation, one of the term must be unity. So what we'll do, we'll factor out 16, so that would give us 16 raised to the power of half times 1 plus 5 over 16 times x raised to the power of half. Now, 16 raised to the power half is simply 4 squared. 4 squared is 16. So we can rewrite it as 4 squared raised to the power half times, we'll apply the binomial approximation. So we have 1 plus half multiplied to 5 over 16 times x. And that should give us the 4 squared raised to the power of half is simply 4 times 1 plus 5 over 32 times x. Now we consider the second term in the numerator, and that is the cube root of 27 minus 4x. So we can rewrite it in the exponent form, so that would be 27 minus 4x raised to the power of 1/3. Then we factor out 27, so we'll have 27 raised to the power of 1/3 times 1 minus 4 over 27 times x raised to the power of 1/3. Now 27 can be written as 3 cubed raised to the power of 1/3 times 1 minus okay, let's write it as 1 minus 1/3 times 4 over 27 times x. So we have 3 cubed raised to the power of 1/3 would be simply 3 times 1 minus 4 divided by 27 times 3 is 81, so times x. So this is the binomial approximation for the second term. Now we plug this value into our expression, so that would give us 4 times 1 plus 5 over 32 times x for the first term, and then for the second term we have 3 times 1 minus 4 over 81 times x divided by I'm going to write it as 6 plus 4x. Then we multiply and then we distribute 4 to each of the term. In the first expression we have 4 plus, so we'll get 5 over 8 times x minus 3 times 1 is 3 plus 4 over 27 times x divided by 6 plus 4x. So this would give us 4 minus 3 would give us 1. Then we add the 5 over 8 to 4 over 27, and it would give us 167 over 216 times x. Then we take the expression in the denominator and bring it up to the numerator, and that would give us 6 plus 4x raised to the power of -1. Now we're going to apply the binomial approximation to the second expression, but before doing that, what we have to do, we have to factor out 6. So we'll have 1 plus 167 over 216 times x. We factor out 6, so that would give us 6 raised to the power of -1. We have 1 plus 4 over 6 times x raised to the power of -1. So 6 inverse can be written as 1 over 6 multiplied to 1 plus 167 over 216 times x, and then we apply the binomial approximation. That would give us 1 minus 4 over 6 times x. Then we FOIL it. That should give us 1 minus 4/6. So 4/6 will be 2/3. So this will be 2/3 x plus 167 over 216 times x, and we'll have 116 times 216 multiplied to 4 over 6 times x squared, but we don't have to consider this term. This will be taken as 0 because we have to neglect the squares of x. Now we are remaining with 1 plus 167 divided by 216 minus 2/3 whole times x, and that will finally give us 1 over 6 times 1 plus 23 over 216x. So this is the final approximate value for the given expression. Let's go to the next question. In this question, we are provided with an expression and then we have to simplify it using the binomial theorem. Here we have to ignore the square and the higher powers of x. So for the first term, we have the first expression is 1 plus 3/4 of x. So it's not raised to any rational number, so we'll write it the way it is. So we have 1 plus 3/4 of x. Now for the second expression, we need a 1 in one of the terms, so we're going to factor out 16. So we have 16 raised to the power of half times 1 minus 3 over 16 x raised to the power half divided by, we're going to factor out 8, so we have 8 raised to the power of 2/3 times 1 plus x over 8 raised to the power of 2/3, and that should give us 1 plus 3/4 of x times, so we have 6 raised to the power of half, which is simply square root of 16, and that should give us a 4, times, we're going to apply the binomial approximation, so we'll have 1 plus half times negative try 6 over 16 divided by 8 can be written as 2 cubed whole raised to the power of 2/3 times 1 plus 2/3 multiplied to x over 8 raised to the power, no, there will be no raising because we have already taken care of it. So this should give us 1 plus 3/4 of x times 4 times 1 minus try 6 over 2 times 16 is 32 divided by, with the 3 and 3 in the exponents will factor out, so that will leave us with 2 squared times 1 plus twice x over 24. Now we can factor out the 4 from the numerator and the denominator, and that leaves us with 1 plus 3/4 of x times 1 minus 3x over 32 divided by 1 plus x over 12. Now we're going to FOIL the two expressions in the numerator, and that would give us 1 minus twice x over 32 plus 3/4 of x, and we neglect the fourth term, which will have an x squared term, divided by 1 plus x over 12, and this will give us 1. So we take the x as the common factor, so we have 3/4 minus 3 over 32 whole multiplied to x, and then we take the term in the denominator and bring it up to the numerator. So we have 1 plus x over 12 raised to the power of negative 1. So this should give us 1 plus 21 over 32 times x. We applied the binomial approximation to the second expression, so that would be simply 1 minus x over 12. Then we FOIL the two expressions, and that would give us 1 minus x over 12 plus 21 over 32 times x, and that would be finally 1 plus 55 over 96 times x. So this is the binomial approximation for the given algebraic expression. Let's move on to the next question. So we have to reduce the given expression using binomial approximation. So let's begin by doing term by term. So we consider the first expression, which is 1 minus twice x raised to the power of 2/3. As one of the term is already 1, so we can go ahead and straight away apply the binomial approximation theorem. So we'll have 1 plus n, which is 2/3, times x, which is negative 2x. And that would give us 1 minus 4x over 3. Then we have 4 plus 5x, which is the second expression in the numerator, raised to the power of 3 by 2. Now we factor out 4, so we have 4 raised to the power of 3 over 2 times 1 plus 5x over 4 whole raised to the power of 3 over 2. So 4 can be written as 2 squared raised to the power of 3 over 2 times 1 plus n, which is 3 over 2, times x, and x is denoted by 5x over 4. And that should give us the 2 and 2 will factor out. So we can factor out the 2. It will leave us with 2 cube, and 2 cube would be 8 times 1 plus 15x over 8. So we can multiply it, and that would give us 8 plus 15x. Then we consider the expression given in the denominator, which is square root of 1 minus x, and that would be simply 1 minus x raised to the power of half, which will be equals to 1 plus half times negative x. So this would be 1 minus x over 2. Now let us go ahead and plug in all these approximate values into a given expression. We'll have 1 minus 4x over 3 for the first expression. That will be multiplied to 8 plus 15x whole divided by 1 minus x over 2. Then we FOIL the two expression in the numerator. So we'll have 1 times 8 is 8 plus 1 times 15 is 15x minus 4 times 8 is 32 over 3x. And then we bring the expression in the denominator to the numerator, and that would be simply 1 minus x over 2 raised to the power of negative 1. So we'll have 8 plus, we have 13 over 3 times x multiplied to 1 plus n, which is negative 1, multiplied to negative x over 2. That would give us 8 plus 13 over 3 times x multiplied by 1 plus x over 2. Now we FOIL this to given expression. We have 8 plus 8x over 2 plus 13x over 3. 8 plus, so we add the two like terms, and that would give us 25 over 3 times x. Let's move on to the next question. So we here have to find the value of the given expression by neglecting the square and the higher powers of x. Let us begin by approximating term by term. So we consider the first term, the first expression in the numerator, which is 1 minus of x raised to the power of 1/3, and apply the binomial approximation. So that would give us 1 plus n, which is 1/3, times x, and x here is negative x. So that would give us 1 minus x over 3 times 1 minus x over 2. That's it. We don't have to consider the higher powers of x. Then we have 1 minus 5x whole squared. So we apply the binomial approximation, and that would give us 1 plus 2 times negative 5x. So that would be equals to 1 minus 10 times x. Then we have 16 minus x raised to the power of 14 in the denominator. So that would be, in order to be able to apply the binomial approximation, we have to factor out 16 so that the term in place of 16 will become 1. So we factor out 16. We also have to take the exponent, so it will be 1/4 times 1 minus x over 16 raised to the power of 1/4. So 16 is 2 raised to the power of 4 times 1/4 times 1 plus n, which is 1/4, times x, which is negative x over 16, and that would simply give us 2 times 1 minus x divided by 16 times 4 is 64. Now we substitute all the approximate values into our expression, and that gives us 1 minus x over 3 plus 1 minus 10x divided by 2 times 1 minus x over 64. So this will be equal to 1 plus 1 is 2 minus, we take x as the common factor, so we'll be left with 1/3 added to 10 divided by 2 times 1 minus x divided by 64. So this will be equals to 2 minus, this will be 31 over 3 times x divided by 2 times 1 minus x divided by 64. Now we're going to factor out 2 from the numerator. So that will leave us with 2 times 1 minus 31. So in the second term we have to divide by 2. So we'll have 31 divided by 3 times 2, which is 6, multiplied to x divided by 2 times 1 minus x over 64. So we have done this so that we will be able to factor out 2 from both the numerator and the denominator, and then we take the expression in the denominator to the numerator. So that will be simply 1 minus x divided by 64 raised to the power of negative 1. So let us apply the binomial approximation to the second expression, and that will be simply 1 minus 31 over 6 times x, then 1 plus negative 1 multiplied to negative x over 64. And we have 1 minus 31 over 6 times x multiplied to 1 plus x over 64. Now we're going to FOIL the two expressions. So we'll have 1 plus x over 64 minus 31x over 6, which should be equal to 1 minus 989 divided by 192 times x. So this is the approximate binomial form.